I call on my friend, my colleague, Dr. Noel Kalicharan, for Digital Math, a revolutionary way to do arithmetic with your hands.
Thanks very much, Shireen. Minister Kalicharan, who has been my friend and colleague since the 80s. People may not know, but we used to do computer courses together. He used to do administration, I used to do the teaching. And we did that until I think he went into government and with the NAR in 1986. But I had continued doing some more work on that. Where is my folder? Something. And this is not meant to embarrass you in any way, but it's really to so that what I will have to say later, what you will see later, will be put in perspective. Okay, so don't feel badly if you don't know the answers. That's probably the norm for most audiences. Okay, I'm just going to call out some simple arithmetic sums and see if you can do them. Okay, 3 plus 5 minus 2 plus 3 minus 6 plus 5. That is? Okay, good. Good so far. Okay, 4 plus 5 minus 6 plus 5 minus 3 plus 2. That is? 7. Somebody said 7. Okay, good. We will ramp it up a little bit. Okay, those were the easy ones. 8 plus 7 plus 5 plus 2 plus 7 plus 6 plus 3 plus 8. That is? Well, we have a mathematician in there. 46 is correct. Another one. 4 plus 9 plus 5 plus 7 plus 3 plus 8 plus 9 plus 4. That is? 49, yes, that is correct. Okay, double digits. 78 minus 25 plus 16 minus 53. Okay, no answer. All right, one more. 49 minus 24 plus 52 minus 12. Okay, again, no answer. Now that's good because, as I said, it will put in perspective what you will see in a short while. Okay, and maybe, well, two things happened this week that I didn't plan on. I came across two articles that, just by accident, and it was surprising how these things just come to be when you're least looking for it. One was an address by the former Minister of Education, Esther Legendre, in 2009. And she was, I don't know, some of you may know, NEOS had a project they call Maths Made Easy. Now, I could talk whole day on why that is not a good thing. You cannot make maths easy. Maths is what it is. Okay, you might make it easier to understand some things, but you cannot make maths easy, really. She was given the opening address, and I said, no, this looks interesting. So I read it. And in a while, I'm going to quote some excerpts from it and make a few points because it's quite relevant to what I'm doing today. And then the other was a TED Talk. How many of you know about TED Talks? Okay, these are some of the most fascinating talks you can ever hear anywhere. It's the most innovative, intriguing, far-thinking talks. And later on, I'll give you the website, actually, www.ted.com and /talks, T-A-L-K-S. And you can browse there. There are hundreds, probably thousands of talks in there. But this one was about, the guy's name was Dan Pink, I think it was. And he was talking about, about motivation, what it is motivates people to do things. And again, I'll mention a little bit about that later on. But I'm so excited about teaching this that I'm actually going to teach you some of the digital math today. So you see that first set of problems I call? I guarantee you, before you leave here, everyone could do that. Okay, you may not be able to do the harder ones because, like everything, it takes some time and practice. But, we'll get to that in a bit. Okay, what I'll do first, I'll show you a video that I took of children at the Jordan Hill Presbyterian School. I've been working with these students for about 5 weeks, since the last week of school, which was, the first week in July, I think. But anyway, the last week of school and during the holidays. So for the last 5 weeks, but I haven't been with them for about 2 weeks, 2 to 4 hours a week. Some weeks 2 hours, some 3, some 4. Okay, so in 5 weeks, let's say an average of 3 hours, that's 15 hours. And the nice thing, no homework. I didn't give them any homework. It's just what we did in class and the exercises we did. And you will see what they've been able to do in that time. So I'll play the video for you, and you'll get an idea of what I'm talking about. Ready? 3 plus 5 minus 2 plus 3 minus 6 plus 5, that is 8. Okay, the reason they're laughing is that, it's okay then.
4
hold on.
plus 5 minus...
He's too hurried to talk. Not to say the answer, just to raise your hand. So they all forgot in their excitement and they all said the answer. So that's why I told them they were hardened. But, all in good spirits.
6 plus 5 minus 3 plus 2, that is...
One started to say 7, but he stopped.
3 plus 5, 1 minus 4 plus 3 minus 5, that is... 3. Ready? 1 plus 3 minus 2 plus 5 minus 6 plus 3, that is... 4. Excellent. 7 minus 2 plus 4 minus 3 plus 1 minus 2, that is... 5. 6 minus 5 plus 2 minus 6, sorry.
False start.
Ready? 6 minus 5 plus 2 plus 6 minus 4 plus 3, that is... 8. Minus 5 plus 8 plus 6 minus 2 plus 3 plus 8, that is... 8 plus 8 minus 6 plus 9, 8, 9, 3, 8, that is... 27. Plus 27, that is... 88, correct. Ready? 23 plus 25 minus 30 plus 51, that is... 69. Ready?
What?
Plus 7, 5.
Okay. Of what is possible. Well, yes. Actually, I sent the book around to people who correspond with me, and one guy from France actually said, Dr. Kalicharan, I have a tagline for your method, playing piano with numbers. That was his, so you're right on the ball. In fact, just by the way, if doing that will actually give them good motor skills because it's the same movement you use to play piano, and other activities, and I think it has other advantages as well. And I'll mention a bit about right brain later on, but the fact that, especially if they use it from young, they'll keep stimulating both sides of their brain, whereas what happens is when they start going to school, only the left side gets more stimulus, and they dispense with their right brain a lot sooner than they would normally do. But I'll mention a bit of that in a while. Okay, so was there anything about the video that struck you as special? Anybody? I didn't come here to talk alone, by the way. So Nothing apart from the fact that they were able to do it. Okay, what I found was interesting in that many times you see demonstrations like these, but what to me was interesting was the whole class was answering. Okay, usually you will find the odd child, the bright child answering. But in this, and these are not specially chosen students. They are, a class, a normal Jordan Hill class. So it's not that we picked out bright children from all the different classes. This is a normal class. They were having lessons, and the teacher said, could you come I'll give you 1 hour to do some work with them. I say, sure. And so it's a typical class, and the same thing occurs all the time. In any group, what we find is most of them get it. Not everybody get it right away, but a much, much higher percentage than will normally get this kind of thing in any other math program. Okay, so I'll quickly go through some of the slides. As I mentioned, the article I was reading by the former Minister of Education. Okay, and the quotes are what she had to say. Okay, mathematics has earned its place in the school curriculum not only because it is critical to research in all fields, but more importantly, it contributes to the total development of the child. I don't think any one of us will dispute that. It is no wonder, therefore, that we would want to imbue our young learners with enthusiasm for mathematics. Okay, again, if you noticed in the video, and what I've been finding is there is an enthusiasm for doing this that you don't normally associate with a maths class. You know how people generally, most people, they don't like maths. Okay, now, and especially young children, if they don't get it right away, they get sidelined, they get turned off. But in this, because they can do things and they have some success, they actually have enthusiasm for doing it. And that's important. We must ensure that we have a critical mass of people with adequate scientific, technological, and mathematical competencies. And my aim, I have always wanted to make Trinidad and Tobago a place where everybody can do mathematics. Everybody, at least even elementary arithmetic. And I think with this method, I have found the key to be able to do that. And maybe the critical mass that we are talking about here, will come. It is our firm belief that individuals who understand mathematics will have significantly enhanced opportunities and options for shaping their futures. Hence, it is necessary to make mathematics more accessible to all students. I dispute that a little bit because mathematics is accessible to everybody. From the time you enter kindergarten, you're doing mathematics, and so it's accessible. The problem is that many get turned off at an early age, and that is where the problem is. If we can get them to sustain that interest a bit longer, then maybe we'll have more people who are numerate. Okay, well, again, another self-truth. Firstly, mathematics is not the most loved subject by our students, both nationally and internationally. An analysis of examination results also suggests that there is a need for interventions to increase the levels of interest and performance in mathematics. Okay, it's one thing to increase interest, but how do you sustain that interest? In other words, we can do fancy things that get them interested. But what do you think will sustain the interest? If you get them interested and they're not learning anything, or they're not succeeding at all, they will lose interest. So to me, what creates interest and sustains interest is success. If they find that they are and it's like anything you do, you tend to gravitate towards the things that you can do. And so with these students, if they can see some success in mathematics, the interest will be sustained. They will want to do more. In fact, some of these students, that also was amazing. So when you're coming back, it's not, oh gosh, this thing finished and we're done. It's when are you coming back? all right? And they're always eager to know when is the next class. Now, I might take some credit for that, but I think sometimes because they probably wanted to get away from the other teacher. So that could be one of the reasons. Okay, in fact, mathematics is one of the least liked. All indications suggest that mathematics can easily become one of the most liked subjects used in digital math. And that is why I'm excited about this method. Okay, so a subject that you can do meaningfully with your hands. What the children were doing, what you were seeing there, they were just using their hands. Okay, and and having practiced a bit with some of the simple problems, they were able to solve these bigger problems quite easily. And I am guaranteeing that digital math will increase the levels of interest and performance in math. Making math interesting will help, but more is needed since interest will wane if there is not enough success to sustain it. Okay, even those who think they were never good at math and never will be become all excited when they realize how much they can learn. And I'll come to an example in a bit. Okay, once mathematical concepts are firmly grounded in the infant years, these become the foundation blocks for further learning. Okay, everything in quotes is part of the minister's speech. Hence, early intervention is critical, for pupils that grasp mathematical concepts in meaningful and appealing ways. In fact, some of the teachers at the school, Jordan Hill School, they came, I had a few sessions with them, and one said, she's not going to ask the principal, but she's going to teach it to her infants class. I said, no, you could ask the principal. She would not have a problem. And because she immediately saw that, yes, this is where is a good place to start, because they don't have preconceived ideas of arithmetic, what is addition, what is subtraction, and it's actually much easier to teach them the younger they are. When pupils experience mathematics in exciting and authentic situations, they are more likely to appreciate its significance and develop a love for the subject. Okay, when they fail to get it, far from developing a love for the subject, they get turned off. Most would say they hate it, but it's not mathematics they hate. It is the fear of not being able to do it. Okay, and I'm saying that in my experience with the program so far, and the few months that I've been showing it to people, meaningful success is easy to come by, giving the student confidence to move on to the higher levels. Some time ago, and this is the example I was talking about, I went to a seminar, and at the end they asked me if I would like to say something. I said no. And then all of a sudden I said, okay, wait, just give me a few minutes. So I started off, of course, this is at the end of the seminar, everybody want to go home kind of thing. So I said, I'm going to talk about maths. Well, of course, everybody started groaning. I said, all right, so how many of you don't like maths? Almost everybody put up their hand. One girl put up 2 hands. So she said, I hate maths. And then I said, okay, all right, maybe, okay, if I had a board, I showed them how to multiply by 11. Now, how many of you know, 43 by 11? Anybody? 473, okay, all right. 433 by 11. How much? 433 by 11. Okay, it's not so easy, but actually you can do this as fast as you can call them. All you do is, it starts with 4, you add 4 and 3, 7, you add 3 and 3, 6, and then it ends in a 3. So the answer is 4, 7, 6, 3. So I show them some of that, and within 10 minutes, I'm not lying, it's with less than 10 minutes, this girl wanted to know, because when I showed them and I gave them problems, she was doing them. She wanted to know where they have classes, where. I said, no, the class is real expensive. She said, no, it doesn't matter. No matter how expensive she's going, because if she could learn maths, she wanted to learn maths. But this is the same girl who 10 minutes before had said, I hate maths with 2 hands. Okay, and it supports my point that what they need is a little success. If you show them that there are things that you can do and do it correctly, then yes, it's not something we're going to hate. And as I said just now, what they hate is not math, but the thought that they can't do math. Okay, and this is the talk I was referring to you about. It's the web page is there for TED Talks. Okay, it's the surprising science of motivation. And okay, that alone will take a whole hour, but just to mention briefly, what he found was that in business, you know, we believe that we give people more incentives, give them more money, more perks, they will work harder, they will work better, they will be more productive. And what he found was that that was not true. Well, it was not true all the time. It was only true for certain things, certain specific kinds of activities. Whenever it came to anything creative, like if you had to come up with a new idea, it didn't work. In fact, it did harm. And he had all the evidence to show that the higher the incentive that you gave people, the less likely they were to come up with something creative. And I'll just read just a bit of the summary. If we really want to get out of this economic mess, and if we really want high performance on those definitional tasks of the 21st century, the solution is not to do more of the wrong things, to entice people with a sweeter carrot or threaten them with a sharper stick. And then it talks about this new approach, and it's an approach built much around intrinsic motivation. Okay, in other words, most of us, we would tend to do things for the reward, for the salary or the medal or what have you. But these things will come. And I always say the reward, if you do the thing, the reward will come. Because if you do it because you love to do it, what will happen? You will do it well. And once anybody does anything well, they can be successful. Okay, so that's what we call intrinsic motivation, around the desire to do things because they matter, because we like it, because they're interesting, because they are part of something important. Okay, and that's what we call intrinsic motivation. So he talks about companies where they tell the employee, for today, do whatever you want. Okay, you don't even have to come to work. Do whatever you want, as long as it's not your regular work. And what they find is in companies like Google, it's on those days that they get the most innovative ideas to move the companies along. So, yes, Gmail came out of that. Okay, so, you know, there are certain well-defined tasks, and the reward things work for that. And he calls it the tasks of the 20th century. But he's talking about the 21st century tasks where you require more creativity. That is where, you know, intrinsic motivation gets you better results. Okay, so what really matters are the more right-brained, creative, conceptual kinds of abilities. Young children are extremely imaginative and curious. And this actually is an excerpt from an article I did in 1996. And it was headline, and the papers used the headline, "Good Grades but Poor Thinkers." So that was, what, 96, about 16 years ago. And I mentioned young children are extremely imaginative and curious. Much evidence suggests that between the ages of 7 and 14, children use both sides of their brain and can learn very rapidly. And it here refers to the common entrance exam in those days, and I think it will apply to the SEA exam nowadays. It is creating intellectual zombies out of our children before they have had a chance to be children. We are forcing them to dispense with their right brain long before they would naturally do so. Most people are left-handed or right-handed, where the use of one hand dominates the use of the other. If children practice digital math, and I really believe this based on all the research I've done, they will use both hands simultaneously, and this will, of course, stimulate both sides of their brain. The secret of high performance isn't rewards and punishment, but that unseen intrinsic drive, the drive to do things for their own sake. I think that digital math is interesting for its own sake, in that I've seen people do it just because one lady called me. She said, I just want to know. And, she bought the book and she is practicing. Okay, a wonderful side effect. To me, the side effect is that you will learn to do arithmetic. with your hands. Okay, so I think that's the talk in terms of the, not my presentation because I'm going to teach you digital math, but in terms of the sort of the theory and the thinking behind why I think digital math will be an important tool in getting children to do arithmetic confidently, or much more children doing that. We do have children, of course, now doing it, but this will, the proportion of children who will do it will be much, much more. Okay, so that was the first part of my talk, and then my helpers. Everybody has, everybody has. Okay, so we'll start. Okay, can you see it? Can you tell if I have a finger touching the surface or it's off? I'm not sure from your vantage point. You can. All right, what you need to do, put down everything else and just hold on to the cardboard. Now, this is usually best done, as you notice, with the children at a desk. So if they're sitting at their desk and they have a flat surface to work on, that will work. But I was told that we will have no tables here, no desks, so I got Carrie and Dina to make up this so you can work with it. Carrie, could I have one? No. And that's why we gave you this. Okay, in fact, on it, it also it tells you how numbers get value. And I'll start by saying that how numbers get value on your hands. Okay. Now, when your hands are off the surface, that's 0. It only gets value when your hand or your finger is on the surface. And that is 1. So, well, maybe I should give you some background. Numbers, we think of a 2-digit number. Think of 75. What is 7? The tens, right? So when it's really, the value is 70, and the 5 is 5 units. Now, what you will do, you will use your left hand for the tens and your right hand for the units. Okay? And then, well, as we go along, you will understand more of how that works. Okay, the first thing is, how do you get value on your hand? Okay, as I said, this is 1. So the right hand only for the moment. So what you could do is put your right finger on it. That's 1. Then put these 2. That's 2. That's 3. That's 4. Okay, now before this talk, I think if I had asked you, well, how much you can count up to on your hands, you would have said maybe 10. Okay, because you have 10 fingers. Okay, but with this, you can count up to 99 and more. Okay, so that's 4. Okay, 5 is the thumb alone, and this is the new idea. Thumb alone is 5. Okay, so this is 5. So if we count in 1, 2, 3, 4, 5, we'll count 1, 2, 3, 4, 5. Okay, so what would be 6? 5 and 1. So that's 6. And 5 and 2, 7, 8, 9. Okay? So on your hand, on one hand, you can store from 0 to 9. In other words, all the digits that we use in mathematics. And of course, you'll do the same thing on your left hand. So on your left hand, you'll store 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means you can store 0 to 9 on your left hand, 0 to 9 on your right hand. You can store numbers up to how much? 9 on your left, 9 on your right, 99. Okay? Right. Okay, so what I want you to do, and I'm going to conduct this part as if I'm teaching children or adults, and that's another good thing. I've taught this to some teachers at a secondary school in Port of Spain, and they were just as excited, probably more excited than the children in terms of, because, for them, they were able to do arithmetic that they couldn't do before. And I think that is always a good thing, being able to do something you never did before. Okay, so what I want you to do is, on your paper, count for me. I will call and you will count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So you should be doing this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, everybody could do that? Okay, go backwards now. 9, 8, okay. 9, 8, 7, 6, 5. Okay, what about 4? This is another key move. So that's 4. You have to, lift up the thumb and put down the 4. So that's 4, 3, 2, 1, 0. Okay, now if you notice, you add by putting these fingers in this order. The order matters. In other words, only this is 2. Okay, that is 2. This is not 2. That doesn't mean anything. This is not 2. That doesn't mean anything. Okay, so 2 is that. And that's the only representation of 2. This is 3. Now if I had 4 and I wanted to take away 1, what would you do? No. Right, because if I take away the index finger, what I have is nothing, not something of no value. Okay, so we add in this direction and we take away in this direction. Because remember, 4 minus 1 is 3, but what's the representation of 3? It's that. So whatever you do, you have to get back that. If I take away 1 and I get that, that doesn't represent anything. So it's 4 minus 1. Okay, 4 minus 1, that's 3. Now, you all know this arithmetic, and the biggest problem you will have is letting that knowledge get in the way. Now, the key to all of this is to let the answers form naturally on your hands. So if we are doing 2 plus 2, you don't say 4 and then put 4 on your hands. You actually do the manipulation, and then you will see 4 on your hands. Okay, as we do some examples, you will see how that works. So, let's do some arithmetic. Easy. 2 plus 2. All right, I can't write there, but maybe I could. Let's make it big. Yeah. Do that. All right, there's a defined way of doing these things. And again, if you have the book or you attend a training session, you will, we explain all of that. And the way you do it is as follows. 2, and you count. You say 1, 2. Plus, and then you say plus 1, 2. That is, and then you look at your hand, and then you see you have 4. Then you say 4. Now another skill you will quickly learn is look at the hand and say the answer. Let me test you. As I said, I'm not sure if you can see if my hand is on or off, but see, how much is that? It's 3 right there. I'm not sure if you can actually see it, but all right. What's that? 2. Hold on. Wait, I think I have a better plan. I'm going to flash the hands and you will tell me what the number is. Okay? Okay, and I'm going to hide the answer so you wouldn't see the answer. Okay, so we're going to do small numbers from 1 to 9 only. Okay, so here you can actually choose what range of numbers you want to be tested on. And then I will say flash new numbers. I'm not hearing all you. Right, okay. I don't know if you're reading the answers from here or you didn't notice, but I can hide that too. Show numbers. Oh no, sorry, that's something. The numbers, these are the numbers here. You can actually see the numbers, so I can hide them. All right, so we'll hide them. Okay, all right, that was too fast or that was good? That was good. All right, we'll go. You can actually speed it up or let me show you how fast it can get. Flash new numbers. I think that's too fast, right? So we're not going to go with that. So set flash speed, that's here. So I can set the flash speed. to move. Okay, I think that might be a good speed. All right, so you just call as you see.
4, 6, 1, 4, 5, 4, 7, 8, 0.
But Solia Bright, that's good. That's excellent. That is, and you notice everybody answering. Okay, it's not just. All right, so we can ramp it up, right? 10 to 50. All right, what I want you to do is don't call it like 25, just say 25. Or if it's 16, say 16. That's probably easier to do. All right, I'll flash it at this speed, and it may be too fast, but we'll see how good you are. All right, too fast. Okay, no problem. Yes, because you have to read both hands now. Yeah, everybody got 0. Good.
1, 0, 4, 1, 2, 4, 2, 2, 3, 1, 2, 3, 2, 7, 4, 0, 2, 4, 0, 0.
Okay, great. Right, so you could recognize numbers. Okay, then the program will let you, if you want to do it the reverse, if I want to know what a 6 is, I can click on 6.
6,
6, and it shows there. If I want 16,
16,
um,
60, 6,
okay. Okay, so you're good at recognizing numbers. All right, maybe I can use this. I didn't plan on using this. Okay, general counting by 1. All right, let me go back. Counting. All right, so this is what I, let's say I want to count this.
1, 2, 3, 4, 5, 6, 7.
Okay, what you should be doing actually is, as it's being done, if you can practice it to get the hang of it. All right, so we're going to go up and down, right? So we're going to count up to 7 and back down to 0.
1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1, 0.
Okay, right. So you can, now let's do some on the left hand. Go on.
10, 20, 30, 40, 50, 60, 70, 80, 70, 60, 50, 40, 30, 20, 10, 0.
Okay. And okay, that's general. Okay, so we're going to do addition with the F1 to F4. Okay, I gave the fingers names. So this is F1, this is F2, F3, F4, F5. What do you think this is? F10. So this is 10, 20, 30, 40, 50, 60. So this is F10, F20, F30, F40, F50. All right, as I said, we concentrate on the right hand. Now, okay, I want you to do 2 plus 2. How would we do that? Now, the way you do it is, maybe I just 1, 2 plus 1, 2. Okay? So you count up to the first number, and then you count, you say plus, and then you count out the second number. So you say 1, 2 plus 1, 2. That is 4. And again, if you didn't know how to do it, the computer will tell you. So you just click on the
1, 2, plus 1, 2, that is 4, 2,
sorry, yes, something.
plus 2, that is 4, 1,
Oh, I think I
Two.
yeah, I clicked the
Plus.
thing twice.
1, Now is 4 to
Okay, then you can do
plus
problem.
2. Now is 4. Ready. 1 plus 1 plus 1.
Okay, it's not, you're not seeing it on the screen, but there's a problem on the right. 1 plus 1 plus 1, and that is the problem it was doing. Okay, now let's do some subtraction. How would we do 4 minus 2? Anybody? You will count up to 4. You say 1, 2, 3, 4 minus 1, 2. Okay? So it's 1, 2, 3, 4 minus 1, 2. Okay? Now, we just we don't have much time, but you will do. Whoever is doing the program will go through a lot of exercises doing problems like that. And then, so that's the first one. So you do it by counting. Okay, I think all of you are good enough that you can do it, as we say, the fast way. So do for me 4 minus 2. So you do 4 minus 2. Okay, so you just put down 4 and you minus 2. Okay, so do 4, and again, if all right, this problem you can't see it, but it's 3 plus 1 minus 3. Again, the computer will show you how to do it, and what I call the fast way.
Ready. 3
Right, so follow, and it shows you 3. So you put down
plus
3
1
plus 1
minus 3.
okay,
Now is 1.
and you see the answer. So you just have to follow the. All right, let's do another problem. Okay, this one is 3 plus 1 minus 4. All right, I want you to. Yeah, we know it's 0, but
Ready.
in the beginning you have to go through the
3
process.
plus 1 minus 4.
Okay. All right.
Now is
So we can
0.
do some more of that. All right. Let me see how much I can challenge you. 2 plus 5. All right. We're not counting. Again, we would probably spend a couple classes going through counting, but we can do it fast now. Let's just do it fast. We know the term is 5, right? So 2 plus 5. Okay. So in fact, if let me put that 2 plus 5, and
Ready.
All right, watch how to do that.
2 plus 5. Now
Okay,
is 7.
7. Okay, you all will be able to recognize that as 7, and so you do 2 plus 5. So that's easy. All right. Okay, I'm going to call, and you do 2 plus 5 minus 1. That is very good. Okay, she's just not even looking at her hands, but she's doing it and watching me. That's really good. That's a sign of an advanced student. Okay. Well, maybe I could give you some exercises. No ones. 2 plus 2 minus 3 plus 2 plus 1. That is 4. How many got 4? Right, so see, and that was quite, if I had called it out, remember when I was calling out the first set, you couldn't do it. But now you can already. And but these only involve the 4 fingers, not the thumb yet. We'll get to the thumb in a bit. All right, let's use just one more. 3 minus 2 plus 3 minus 2 plus 1. That is 3. Okay, good. All right, we'll do some with the. See how good you're getting in maths already? 3 plus 6. Okay, that's a little tricky. 3 plus 6. You can do it in steps if you want. 3 plus 5 and 1. After a while, you'll just drop the 6. Okay? And if you have the minus 6, you'll just lift up the 2, the 5 and the 1. Yes, 3 plus 5 minus 6. minus 6. Okay, 3 plus 5 minus 6. You have to minus a 5 and a 1. But it must be this one. You can't minus any other one. You couldn't minus these two. Okay? So 3 plus 5 minus 6. Okay, 9 minus 7 plus 6. Okay, so 9 minus 7. You minus 5 and 2. Right? Plus 6. 8. Okay, 8 minus 2 plus 3 minus 5. That is 4. Great. Okay? So, and what happens is you get used to the movement so easily. Like if you see the children, they will do 3 plus 3. They will do 4 plus 3. You know, as soon as they hear the numbers, once they go through the exercises, as soon as they hear the numbers, the fingers move to, you know, to add or subtract or whatever. So 4, all right, let's do that one. 4 plus 3. All right, so what we're doing, you're adding 5 and taking away 2. So 4 plus 3, 7. 4 plus 3, 7. Okay? Easy one. 2 plus 3. Okay, again, not so easy. 2 plus, you can count. 2 plus 1, 2, 3. No problem. Yeah? Or that's 5. Or you can, what would be the formula? If the 2 plus 3, how do we add 3? We add 5 and take away 2. Okay? So, you know, we will introduce the formulas. For little children, it will take a little longer because they will have to learn that in order to add 3, you must add 5 and take away 2. And that's, I know you have to go, so you feel free to go anytime you want. Okay, Sheree, thanks. And you want to go to left hand. Let me ask you, suppose you had 4 plus 9. How would you do that? See if you can figure it out. I'm sure some of you will. 4 plus 9. Okay, we all know the answer, but how would you do it on your hands? Okay, 4. Now you want to add 9, but what do you have? Remember, your left hand is all 10s. So you can add the 10. But if you add a 10, that is too much. Okay? So you must then take away 1. So it will look like this. 4 plus 9. And you do it in one step. As you drop the 10, you pick up the 1. And your hands give you the answer. Now notice how, just do this. Let me see how good you are. 4 plus 9, 9, 9. Okay, 4 plus 9. Okay, drop a 10, pick up 1. Plus another 9. Huh?
So every time you drop, you pick up 1?
Well, if you add in 9. If you add in 9, yes, yeah, that's right. So if I add in 9 to that, I drop a 10 and pick up 1. If I'm adding 9 to that, I drop a 10 and pick up 1. So I have, and notice the answer is there immediately. So you can do 4 plus 9 plus 9 plus 9. As fast as you can call it. 4 plus 9, 9, 9. 31. You know, as quickly as that. And I hope to see you practicing. We have copies of the book available. The retail price is $156, but for today's people, if you want a copy, $120. So.
I just want to share with you 3 sums in political maths. The first one was in 1958 to 59, when the Federation took place in the Caribbean, and there were 10 countries. And then there was a referendum in one of the countries. And Dr. Williams, who was then the premier, said in his version of political maths, 10 minus 1 is equal to 0. Could we count this on our hands?
1 from 10 is 9.
And so the Federation collapsed. The second political maths took place between 1986 and 1991, when the country voted in a government with 33 seats. And by 1991, that government only got 2 seats. So here it was 33, became 2 in 5 years. And therefore, what caused that? An election. The third one that perhaps is most clear in people's minds today has to do with the 1818 situation just a few years ago, when both parties got 18 seats in a 36 chamber. And therefore the issue was which 18 was greater than the other 18. How do we solve that maths problem? And then the solution came from the then president of the country, who said, spiritual and moral values will determine which 18 is greater than the next 18. Anyway, I thought that this excited me to think about political maths. And in the same way that you have found a way to do counting with your hands, I hope you can find a solution to do counting somehow so that political maths can make sense in the future.
It will never make sense.
I want to thank, it will never make sense. But I want to thank you for being here. I know a vote of thanks to be given, but I see a wonderful crowd emerging in these sessions, and I'm very, very pleased to see the growth with which this little discourse is taking place on issues that will generate some thinking. But I sense from a commercial point of view, and we have here a very young man who just completed his PhD in financial economics, and I was able to ask him to come, and he could tell you that perhaps you're in for innovation globally, if what you said is correct, that you have devised a system here in Trinidad and Tobago at the University of the West Indies. We don't know what the commercial implication of this could be worldwide when it is tested and tested and tested, and the results become very practical for everyone. So what you engage in here is really an early expression of innovation in learning. And I want to thank you very much, and thank all of you for being here, and thank Vido and his team and Ramjatan Singh for once again putting things in order for us to share another hour of enlightenment and innovative thinking, intrinsic, as you put it. Thank you very much.